Assalamualaikum and good day all. Today I would like to discuss about chapter 11 on centrifugal pumps, expansion tanks and venting. So actually this topic will be a last topic in this semester for basic component of HVAC. Okay, so we go first on the topic pumps. Yeah. So based on the types of the pumps, we can separate by two types. The first, positive displacement. The second, centrifugal force. Yeah. Okay, under the positive displacement, we can find in the reciprocating, gear, vane, screw, rotary. And then under centrifugal force, we can get the other type in the using an application of the centrifugal force, in the hydronic and cooling tower water system. So as we know, centrifugal is same like the condition of fan, using the uh, a blade, with the axial as input, and then output can be the axial and or radial. Okay, and the positive displacement used only in the specialized case in the HVAC work. In the centrifugal force, maybe we can see in the application of hydronic, cooling tower water system, and then positive very reliable, rugged, and efficient. Okay, this one may be specific, more specific application. Okay, now we go to type of centrifugal pump system, as I mentioned before, where the suction occur on the axis uh, axis direction, and the output is from the radial direction. So increase in velocity convert into potential energy. So from the by the velocity we can convert to potential. So water enter impeller via I, see, from the axial, and the water is forced radially outward direction. This one is a radial direction to outward, and water velocity is increased. The water is guided toward discharge opening by pump casing involute, and the faster suction section of the pump casing, the flow area increases, therefore velocity decreases, resulting in increase the pressure. So by increasing the pressure, actually velocity will decrease, because for illustration we can describe a condition like same like the highway. If we have much of the vehicle in the highway, and then we have the one of what we call uh, in the junction. So what happened? The highway will got the jam. Yeah. If I have a high volume of the vehicle in the highway, and then in the same time we meet one point from the two junction, like Y junction, and then we meet one point with the high volume of the vehicle. So what happened? The pressure will be higher in that point. So what happened if the pressure higher? It means the velocity is low. So if the high velocity, we can illustrate by the number of or volume vehicle in on highway is quite small, so we can use high speed, yeah, on the road, on the highway. So we can illustrate the same condition into the highway condition. So that's why the velocity and pressure is opposite way. Okay, terms used in the pump and the calculation. So the first term is BHP, is the same term actually that we use in the fan calculation. We have a BHP, brake horse power as input, and then WHP, water horse power output, and then GPM, gallon per minute, and head, H is a head, meaning the static head of the pump is the maximum high pressure it can deliver. So we can use this term in the calculation of the pump. Actually, this calculation already learned in deep in the fluid mechanics. Okay, pump character is influenced by the several parameters. We have the pump pressure head, we have a parameter delivered, flow rate, horsepower required to drive to the pump using curve flow rate, vessel head, flow rate, vessel BHP, flow rate, vessel efficient. So anything will influence into the pump characteristic. So this uh, also we calculate by using efficiency parameter in the calculation formula. So we can see the formula. Performance E equal to power output, as mentioned previously. Power output is WHP and divide by power input as BHP, and then times to 100%. Okay, so WHP itself, we can derive by GPN, gallon per minute, time to head, and time to SG. This one is converts unit, converts unit. Should be from the gallon in the feet in the British unit. Okay, we can see one example here. Chill water. This example actually how to implement this formula. A chill water pump for the air conditioning system in a building is delivering 200 gallon per minute at a total head of 36 feet of water. The manufacturer lists the pump efficiency as 60 percent, the efficiency. At this condition, calculate the minimum power needed for motor that should be used to drive the pump. So this actually to show the pump characteristic. Okay, we can solve by formula first. WHP here, gallon per minute time to H, blah blah blah, divide by 3,960, and then we can got the WHP is 1.82, and then we go to the BHP. BHP is WHP divided by E. This one is because the question is BHP, so just modify this formula to get the BHP. Okay. Okay, actually this one is a 60 hertz country. Is mean certain country use uh, 60 hertz power of electricity, power supply to the every home. So in the Malaysia, maybe we will use the second one, at the 50 hertz of the power supply. So around 240 volt. Yeah. So this one, the graph is that mentioned in the from the parameter, how we plot, and between the head and the flow rate, we will perform like this: the curve, BHP to the flow rate, and then efficiency to the flow rate. So we will choose the condition of the pump within the this condition. So maybe we don't want use the maxima of the power of the pump. Maybe around maximum is 75, the power of pump. So maybe around here, around here, around here. So we cannot use all the whole capacity of the pump. Okay, how to select pump? Yes, as mentioned before, because we are in the 50 hertz country, we will get this performance of RPM pump, and then operating near the point of maximum efficiency. So we should be select the pump based on the calculation during get the NPSH, net positive head system. So should be in the maximum is 75% of the power. So we should be play a safety to the pump selection, so not more than 75% of the pump operating system. And then flat head curve, hydrodynamic system, large change in the flow rate. So maybe we can choose around here for condition of the pump condition. So around 70% of the performance, maximum performance of the pump. And then steep head curve, gradually change in the pressure resistance, maintain constant flow rate. Those will be we design in the constant system. So maybe in the steep head, maybe we'll choose here, and then for flat head, we choose here. Okay. System characteristic. So we can satisfy the system characteristics is by using this formula. So HF1, HF2 divided by HF1 equal to gallon per minute 2 over to gallon per minute 1. This one actually relationship within the pressure loss to the supply, water supply to the pump. This condition. So if we select the point 1, the certain part, certain position, and then we measure to other part, that one we call the position 2. So HF2. So how many had lost from the point 1, position 1 to position 2. So how many had lost, and then we calculate. Not calculate, maybe we can also measure the supply liquid from that point. So what happened? So this we can make a equation relationship between them. Yeah? So we call the characteristic of the piping system. So can be plotted for any piping system by calculating pressure loss at a few different conditions. Flow rate system, frictional resistance. Okay, we try to input in the calculation the frictional head loss. So we can input the frictional head loss there inside the formula, how to calculate the NPSH. The curve takes only frictional pressure loss, therefore only for closed circuit. So only this one condition For closed system, it means closed is not open to the atmospheric condition. For open circuit, static head must be added to the neck height of lifted water to find total system resistance. So other condition, if we have cases open to atmospheric, this will be uh, add height enough to that condition. So how many head loss or head? Head it is mean the uh, differentiate within the top of the fluid to the pumping system. So how many height? Okay, we have a graph here within the head and the flow. So almost proportional, but still have the certain curve here. The point of intersection of system characteristic and pump characteristic flow head curve is always be actual operating condition for the system pump condition. Okay, how to implement this one? We can see the one example of a piping system has a pressure loss due to friction of 30 feet water when the flow rate is 60 gallon per minute. If the flow rate were 80 gallon per minute, what would be pressure loss due to the friction? So you can use this formula from this kind of relationship formula. So we can modify to find out the head loss in the position 2. Okay, now we can answer the question. Okay, and the pump system, actually, we have a pump similarity law. Pump similarity law, we have three actually. The first one, flow is proportional to shaft speed or impeller diameter. So we can calculate from uh, uh, speed, speed 1, speed 2 are equal to impeller diameter 1 and diameter 2. So this one is we call first law of similarity pump. And the second one, a relationship within the pressure proportional to square of shaft speed or impeller diameter. So we can put a calculation formula with this relationship. P1 per P2 over equal to N1 per N2. So is uh, can be make equation relationship. And then the last one, law 3, power is proportional to the cube of shaft speed or impeller diameter. So still comparison also with the uh, uh, pressure and then diameter of impeller. And then in the pump construction, we have several type here. In the positive and then also centrifugal. So different pump construction. So we have characteristic first by the pump similarity law, and then we try to select the type. Okay, in the calculation of net positive suction head or NPSH, why we need to uh, calculate the NPSH? Because we to avoid uh, something of distortion in the piping system because of the cavitation, okay, in the pump section, suction. As we know, the cavitation will be occur in the around the blade because of the bubble, high temperature of can create the bubble, so will be uh, losing in the pressure. Okay, where water pressure is too low, vapor pressure of water maybe fall to corresponding T saturation. So should we understand if we try to design something to transport the liquid, it should be characterize first what type of the uh, liquid system. So we should be know where the position of T saturation. So T saturation mean when the uh, liquid come to vapor. We should be avoid this condition because when the high pressure will be I'm sorry will with high temperature will be uh, create the uh, the boil. So when the boil come, it mean the bubble will produce. So we will should be avoid this condition. The bubble will decrease the pressure inside of the piping system. Water flash into the steam bubble maybe collapse in the pump, water rush in the cavities, erratic operation, noise, and possible damage. This one is unwanted in the uh, pump design. So we don't want the very noise will we create the high vibration. And then the pump operation should be is positive NPSH. Positive NPSH. Obtained from manufacturer should be maintained. So it's not work more than blah blah blah. So they have the limitation. NPSH must bigger than pump require or else chain piping arrangement. So if we calculate, we got the NPSH number. So we select pump is to be higher than NPSH number. Okay. So normally in open systems, suction lift to pump. So actually, yes, when the open system and then the influence of the outside air will combine, will come into the pump system. So the air will trap inside of the pump. Expansion tanks. So why we need expansion tank in the piping system? Common Commonality between booster pump station application is necessary to maintain pressure in the water supply system. So what we do, we try to develop in the design, our design piping system. So we have the expansion tank. So expansion tank will maintain the pressure inside. So inside of tank is should be it mean high pressure will maintain inside the piping by fluid. We pump the fluid inside in the tank, and then tank will be keep the high pressure inside. So when the supply to the piping system, the tank will be maintain the pressure. So easy to transport the liquid. So water expand as the temperature increase. Yes. So we try to maintain a condition by keep the parameter. So while we want to keep water expand as the temperature, we should be careful to the temperature. So if the water got the high temperature for our environment condition, should be high pressure, and then the tank we will uh, absorb that pressure. In hydronic system must provide the allowance. So how much we try to give the limitation, so not cross that uh, condition. Yeah? Piping and equipment might be break, of course. We try to keep the pressure. Solution: an open expansion tank at a higher point in the system. but disadvantage corrosive effect due to the continual exposure to the air. So actually, we try make mix within the air and then with the water. So what happens inside this condition will create the corrosion inside of the system, in tank itself or piping itself. So better solution, a closed expansion tank containing or air or N2. Yeah. So when water expand, compress the gas. Actually, this one, the figure also already described. One part in the pipe in the tank. On the top one is have the vent. Vent system is to control the pressure and also the avoid the contain the air inside the system. So we can remove by using the vent. But this one we will discuss later on after this one, after the compressed tank. Okay, system pressure control. Okay, this one is a parameter we can use to control pressure. So we can use the maximal level P based on the permission equipment pressure. We can see from the gauge reading. So we should be avoid the maxima or the allowable P. And then steps, proper sizing of compressor tank. Design is in designing location of the compressor tank. So will be avoid by influence in the temperature. So temperature increase will be increase the pressure tank itself. So other minimum pressure based on the P at any location is less than P set of water. So to avoid the create the boil of the water. The position is a pump suction. So be maintain the temperature below to P set saturated. And then P at any location is less than P atmospheric. So it should be less than a P atmospheric. So it means the outside will be higher and then the inside there is lower, inside the piping. Okay. This one already in compression tank size, we can design by using this formula uh, by parameter of the pressure and also the volume that uh, we try volume of the fluid, uh, volume of fluid we want to operate in our design. So we can calculate by this formula. Then we can create the compression tank of volume. So should we know first the pressure operation in our design. Should we know first. Then we can calculate to get the size of the tank. So total pressure that will be influenced in the system is from the static pressure and then initial pressure and then also pressure that influenced by temperature and then pressure from the pump itself. So the pressure from this one total we can calculate of the compression tank size. For the compression tank size designed for special case for residential small hydronic system calculation is not necessary. Okay, so this one is uh, maybe the pressure is not higher and then maybe not high risk, maybe low risk. So just follow the table from the manufacturer. We can select. And this one, what I mentioned before in the venting. Venting is one part, yeah, to remove the air that trapped in the inside of the system, and then we try to remove to the outside because of the maybe air can reduce the uh, what in the pressure inside the piping. So we try to remove, and then maybe higher air trap inside also will be create or the corrosion. So the solution, remove the gas and separate device at the tank connection. So we have like the compression tank, expansion tank, to separate within the air. So we trap the air inside the tank, and then because of differentiate density within the air and the liquid, so the air will be in the upper position. So we put the vent on the top one, and then we can control the pressure and also control the quantity of the air trapped in the piping system. A vent at a high point in the system, of course. So from the uh, tank, we position it. The vent is upper, the higher point. Pitch horizontal piping slightly up toward high point with the installation. So when we try to install in the piping system, so should be up toward the install vent at the each terminal unit. So we need to install every unit. There are automatic air vent, but if stick to open position cause water damage. So therefore consider, should be considered. It should be auto, sir. We can design to auto open. An eccentric type reducing fitting is recommended when changing pipe size. Okay. Need control because air presence will block the water flow. Yeah. As I mentioned before, the air will trap in the piping system will drop the the pressure because air considered is compressible. So we trap inside the piping, so the pressure will be reduced, yeah, by the compressible of properties of the air. So other air and the water is promote the corrosion. That's why we try to develop in vents in the our every component. So for energy conservation, so we keep the provide air venting in the design installation and maintain to avoid reduction of efficiency. Do not allow extra pressure loss in piping a safety factor. Please keep to uh, make extra, don't make the extra uh, loss in the piping system. So we can reduce by selecting piping selecting, uh, not much of a equipment, piping equipment also will be reduced, will be increased the head loss. Such as we add more component in the piping like vein, uh, joining, elbow, anything. So will be increase the head loss. Select pump the range uh, of greatest efficiency. So around in range 50 and 70% of max capacity. So we don't want to uh, consider to use uh, of what pump to higher or not lower, less than the 50, because the what we see from the curve just now. We try to get on the curve on the top of the performance. Okay, I think that's all for chapter 11, last chapter for basic component. So for your task, please submit summary for this chapter into the ULearn of to consider your attendance. Okay, that's all. See you later. See you around. Assalamualaikum and good day all.